Hi guys, here are your day 2 notes for section 6.4. 6.4 is all about simplifying nth root radicals, right? So I told you there's going to be other roots that we take other than square roots. So yesterday we started with square roots to try and get you guys comfortable because they're the ones you are used to, even though you had to see it with a variable for the first time. So today we're going to focus on third root radicals, okay? So third root radicals are also known as cube root radicals because when you times something by itself 3 times, that's known as cubing it or a cubic. So the third root is also called the cube root. All right, so this is what the symbol looks like. When you see a little 3 tucked in this corner, that means you're taking the third root of whatever is underneath it, right? So this is the third root radical symbol. So if you're going to work with third roots, you have to know who your perfect cubes are, or who are your perfect third powers. So if you take 1 and cube it, 1 times itself 3 times is 1. So 1 is a perfect cube. 2 to the third is 2 times itself 3 times, so that's 8. 2 times 2 times 2. So 8 is a perfect cube, or a perfect third power. 3 to the third is 27, 4 to the third 64, 125, 216, 343, 512, 729, and 1,000. And again, this list just keeps on going and going and going and going. I stopped there. All right, I probably won't assign you ones that you'll need to know anything bigger than 1,000 anyway. But all of these numbers right here are known as your perfect third powers. These are the numbers that you can take the third root of and get a whole number back. So if I asked you, what's the third root of 343? The third root of 343 is 7. It's what number did you times by itself 3 times to equal 343, okay? So these will be the magic numbers that you'll want to use when you simplify a third root radical. Because again, these are the numbers that you can take a third root of and get a whole number back. All right, so let me just go over a few more examples of that. So if you are asked, what is the third root of 8? You are really being asked, what times itself 3 times will end up equaling 8, right? What times what ends up equaling 8? Well, if you look on your list, the third root of 8 is going to be, well, who did you cube to get 8? 2. So that would be 2 times 2 times 2 equals 8. So the third root of 8, guys, is 2. Okay, what's the third root of 512? Well, what's the third root of 512? Look on your list. 512, the third root of it is 8. All right, because 8 times itself 3 times will get you 512. Okay, now here, look at this. When we were dealing with square roots, you weren't allowed to take the square root of a negative number and get a real number answer. That's because nothing times itself 2 times or nothing squared equals a negative number. But if you're asked the third root of negative 64, think about what you're being asked. You're being asked what times itself 3 times ends up equaling negative 64. Well, guys, something times itself 3 times could end up negative. So if you go to your list, the third root of 64 would have been positive 4. So the third root of negative 64 is negative 4 because negative 4 times negative 4 times negative 4 equals negative 64. So the answer to this is negative 4. So you are allowed to take the third root of a negative number and get a real number answer. There are no imaginary answers when it comes to the third root. You can still get a real number answer when you take the third root of a negative number. So I does not come out to play when you take the third root of a negative number. Okay? All right, so again, I just wanted to put that in writing for you guys. So there will be no imaginary answers for third roots. Okay, so let's practice by simplifying. So let's say you were asked, what's the third root of 216? Well, if I'm you guys, I would keep this list handy. Look to see if 216 is on this list. It is. So the third root of 216 is 6. Okay, well, what's the third root of negative 729? Well, go to your list and fingers crossed that 729 is on there. 729 is right there. So the third root of 729 would have been positive 9. So the third root of negative 729 would have been negative 9 because it would have taken a negative 9 to times by itself 3 times to end up equaling negative 729. Okay, now I just want to show you on a calculator I know you guys are all familiar with square root buttons, like right there in blue. That's your square root button, right? But if you want to take the third root button, then you're going to have to find on this calculator, mine looks like this. It looks like that little empty box next to a square root. That's how you can make it any root you want. So if I wanted to take the third root of 216, first you'd have to put 3 on your screen. 3. Then you would go get that little weird looking square root button right there. But I have to go to second. So second, grab that little funky root there, and then it automatically makes it the third root of that number. And now plug in 216, and then it's automatically taking the third root of 216. We already know the answer is 6, so it should say 6 when we hit enter, and it does. The third root of 216 is 6. All right, let me show you on this one. A lot of calculators have... There's your square root button right there. Then they have this button, which looks like a little X in that little corner. That means you can make this any root you want. You can make this the third root, the fourth root, the fifth root, the sixth root, and so on, just like the other calculator. So again, the important thing is whatever root you want to take, the third root, the fourth root, whatever it is, you have to put that root on your screen first. So the first thing I have to do on an empty screen is put a 3 on there because that's the root I'll be taking. Then I have to go get that little weird looking square root with the X there. So mine's the second button, and then I have to hit there, and then that's going to be, it's giving that X right there a value of 3. So this is now the third root of whatever number you plug in. Oops, sorry, I hit my camera. All right, so now let's put in 216, hit enter, and it should be taking the third root of 216. And it did. It's 6. Okay, sorry, my calculator has a little ding in it. All right, look here. Let's do it. Third root of negative 729. We know the answer is negative 9, right? So go on an empty screen, put a 3 up there because that's the root we'll be taking. Go get that little weird looking root button. So now I'm taking the third root of negative 729. So it looks like that. And now hit enter, and it's negative 9. Okay, so again, your calculator can do this for you. The problem is when they want you, you're looking again for that little weird looking button on your calculator where you can put it in first. Okay, that's your little on a calculator button that you would use. All right, the problem is the calculator isn't going to help you when you're asked questions like this. What if you're asked to simplify the third root of 24? Well, if you go to your list of perfect third powers, 24 isn't on this list, which means it's not a number you can take the third root of and get a whole number back. If you asked your calculator, what is the third root of 24, it should give you a decimal because it's not on our list. And it is. It's like 2.88. Well, we don't want decimals, right? So you're going to simplify this just like you would a square root, except now you have to find the biggest number on this list that divides evenly into 24. So what's the biggest number you can take a third root of that divides evenly into 24? And that would be 8. 8 is the biggest number you can take the third root of. So you're going to rewrite this as the third root of 8 times the third root of, well, 8 times what gets you 24? 3. So now you can take the third root of 8. The third root of 8 is 2. And then the third root of 3, well, again, 3's not on this list, right? So you can't take the third root of 3 and get a whole number. So he's your leftover that stays under the radical. And that is your simplified answer for the third root of 24. Remember we said this is like 2.88? Watch. When you type the simplified version in, you get the same answer. 2 times the third root of 3, and you get 2.88. You get the exact same answer because this is just the simplified version of that. So that's what you'd want to put as your simplified answer. And the most important thing is you don't want to lose your little root, right? Because if you don't put something here, then this symbol is assumed to be the square root, and that completely changes your answer. So don't forget to put the little third root button in, number in there, okay? Look at the next one. What's the third root of 128 simplified to? We'll go to your magic numbers and look for 128, right? 125, 216, 128 isn't on here. So then you have to find the biggest number on this list that divides evenly into 128. So 216 won't, 125 won't, 64 will. So we can break this up into the third root of 64 times the third root of, well, what's left over? 64 times what gets you 128? 2. All right, so now what is the third root of 64? The third root of 64 is 4. So that's 4. And then the third root of 2, remember, 2's not on this list. You can't take the third root of 2. He's your leftover, so he stays underneath the radical. And your simplified answer is 4 times the third root of 2. Okay? All right, look at this one. What if you're asked to simplify the third root of 4,000? Well, we'll go to your list, and we don't have up to 4,000, so you could test it on your calculator. What's the third root of 4,000? Let's see if it's a perfect square. The third root of 4,000. Hit enter, and it's not, right? It's 15 point something. So then you're going to want to find the biggest number you can take the third root of. Now, again, I'm trying not to assign you problems that go more than 1,000, but 1,000 is the biggest perfect third power that will divide evenly into 4,000. So we're going to break this up into the third root of 1,000 times the third root of, well, 1,000 times what gets you 4,000? 4. So now the third root of 1,000 is 10. And then the third root of 4 is your leftover that you can't reduce. So you leave it, or it is reduced, I should say. So you leave it just like that, and that is your reduced answer. So this should feel just like reducing a square root, except you're using a different list of numbers to break it down. Okay? All right. Well, yesterday we saw that sometimes you have to take the third root of a variable. So I want to go over variables with you before we get to like the homework type problems. Okay. So let's say you have to take the third root of a variable, right? Well, remember, just like with square roots, squaring something and square rooting it were opposite operations. They canceled each other out, right? So if you take the third root of x to the third, this third root and that power of 3 cancel each other out, and you're just left with x. The third root of x to the third is x. So each x to the third, you third root, it will equal x. So that's kind of like your baby. You want to be able to take the third root of x to the third, right? Because that will get you a just x. All right, so let's practice this. So you should have seen your square roots and you know you shortcut by now. So let's see what this one does. So let's say I ask you to simplify. What is the third root of x to the third? Well, everybody should know the answer to that. The third root of x to the third is x, okay? Easy, nice, it's done, right? Okay. Well, what if you were asked to take the third root of x to the sixth? Well, the long way is to figure out, well, how many x's to the third live inside of x to the sixth? Because every x to the third that lives inside of that, we're going to be able to take the third root of. So the long way is to rewrite this as the third root of x to the third times x to the third, because 3 plus 3 is 6. So I'm able to expand this into x to the third times x to the third. So now I'm able to take the third root of each one of these, and then the third root of x to the third is x. The third root of x to the third is x. X times x is x squared. So the third root of x to the sixth is equal to x squared. That's what you'd want to times by itself 3 times to get x to the sixth as your answer, right? But remember, just like yesterday, there's a shortcut to taking the root of an exponent or power. The shortcut says to take your variable and you're going to take the power and divide it by the root. All right, so this would be the third root of x to the sixth would be equal to x to the power 6 divided by root 3 is equal to x to the, what's 6 divided by 3? It's 2. So x squared would be your answer. So this is the shortcut instead of having to rewrite it, right? So all you do is take your power and divide it by your root, because that will tell you how many x's to the third live inside of x to the sixth. All right, so look at the next one. What if you were asked to take the third root of x to the ninth? Well, instead of having to rewrite it in all of these x's to the third, your easiest way to do this is to write it as x to the power 9 divided by root 3. And what is 9 divided by 3? It's 3. So the answer is x to the third, right? Okay, what about the next one? What is the third root of x to the 12th? Well, the shortcut would be to rewrite this as x to the power 12 divided by 3. And what is 12 divided by 3? It's 4. So the answer is x to the 4th. So the third root of x to the 12th is x to the 4th. And that's the fastest way to take the root of a variable. Okay, well, like we saw yesterday, what happens if the power doesn't divide evenly by the root, right? We did problems like that yesterday with the square roots. Okay, so like I said, what happens when the power does not divide by the root? Well, in that case, that means you're going to have to rewrite it a little bit, and there will be a leftover variable stuck under the radical. You won't be able to completely get rid of the radical. So look at this. What if I asked you to take the third root of x to the 4th? Well, remember how we first started this. Really, what you're trying to do is figure out how many x's to the third you can rewrite x to the 4th as, right? So we would start as x to the third times, I can't put another x to the third because that would make x to the 6th, and I'm only trying to make an x to the 4th. So once you break it up into an x to the third, all you need is another x to make it add back up to that 4. So there's only another x left over. So now it's going to be, you can split this into the third root of x to the third times the third root of x, right? Well, what is the third root of x to the third? It's x, right? Power divided by root 3 divided by 3, it's 1. It's x to the first. And then I can't take 1 and divide it by 3. He's your leftover that stays underneath the radical. So the third root of x to the 4th will simplify to x times the third root of x. That 3 is a root, okay? And that is your simplified answer. So if your power doesn't divide by your root, then you're gonna have something that's stuck under the radical in your answer. You won't be able to break it all free. All right, look at here. What if I wanted to take the third root of x to the 5th, right? Well, we're supposed to take the power and divide it by the root. Well, 5 doesn't divide by 3. So I wouldn't want to rewrite this as x to the power divided by root, right? Because they don't divide. So I don't want to do that. So what we're going to do is we're going to break him up into a exponent or a power that will divide by 3. So we're going to break this up into the third root of what's the closest number to 5 without going over that will divide by 3. It's 3. So we're going to break this up into x to the third times, well, how many x's are left over? X squared, right? So now I can rewrite this as the third root of x to the third times the third root of x squared. Well, the third root of x to the third is x. And then I can't take the third root of x squared because 2 doesn't divide by 3, and nothing smaller than 2 will divide by 3. So I can't split him up. He is the leftover stuck under the radical part. So it's going to be x times the third root of x squared. And that is your simplified answer. The third root of x to the 5th simplifies to x times the third root of x squared. Okay, so it looks a little bit different, but it's kind of like the square roots, right? We just want to break up that power into some number that will divide by 3. All right, so look here. What if you were asked to take the third root of x to the 7th? Well, if you did this by the shortcut, it would be x to the power 7 divided by root 3. But 7 doesn't divide by 3, so I don't want to do that yet. So we're going to break this up into the third root of x to the, what's the closest number to 7 without going over that will divide by 3? It's 6. So we're going to break this up into x to the 6 times how many x's are left over to get you back to 7? Just 1, right? Because 6 plus 1 will get you x to the 7th. So now I can rewrite this as the third root of x to the 6th times the third root of just x. All right. Well, this power will divide by 3, so I can do this one. The third root of x to the 6th is x to the 6 divided by 3 is 2. So that's x squared. And then I can't take the third root of x. He's the leftover part, so he just stays the third root of x. So this simplifies to x squared times the third root of x. So every time the power won't divide by the root, there's going to be something left underneath your radical, okay? And whatever's left under your radical should have an exponent lower than 3, which means it'll have an exponent of 2 or an exponent of 1. But anything bigger than 3 would have divided by 3. So we could have, or at least something, a number, one of the numbers were divided by 3, okay? All right, look here. What if they asked you, what's the third root of x to the 8th? Well, again, if you tried to shortcut this, it would be x to the power 8 divided by root 3. But 8 doesn't divide by 3, so we don't want to do that, right? So we're going to break him up into something that will divide by 3. So we're going to break this up into the third root of x to the, what's the closest number to 8 that will divide by 3 without going over? It's 6 again. So I'm going to break it up into x to the 6th times x. Well, how many x's are left over to get you back to 8? 6 plus 2 would be left over this time. Okay, now I can split them into their own radicals. The third root of x to the 6th times the third root of x squared. Well, 6 divided by 3 is 2. So I can get rid of his radical, and he's x squared. 2 does not divide by 3, and nothing smaller than 2 divides by 3. So he's the leftover part that is stuck underneath the radical. So your simplified answer is x squared times the third root of x squared. Okay? So again, you got to get used to it. All right, let's keep going. What if they asked you what's the third root of x to the 10th, right? Well, shortcut would say it's x to the power 10 divided by root 3. But 10 doesn't divide by 3, so I don't want to do that, right? So we're going to break him up. It's going to be the third root of x to the, what's the closest number to 10 without going over that will divide by 3? It's 9. So we'll break him up into x to the 9th times, well, how many x's are left over to get back to 10? Just 1, because 9 plus 1 is 10. So now I can rewrite this as the third root of x to the 9th times the third root of x. What's up, bud?
Mom, can she have an iPad?
Yes, she can. Okay. All right, so now we can simplify this. Since 9 divides by 3, I can get rid of his radical. So that'll be x to the 9 divided by 3 is 3, so he's x to the third. And then the third root of x, because 1 doesn't divide by 3, and I can't break him up, he's the leftover stuck under the radical part. So then it's the third root of x. So x to the third times the third root of x is your simplified answer. Okay, now I just wanted to go over these two special cases. What if you were asked to simplify the third root of x squared? Well, the shortcut would say this is going to be x to the power 2 divided by 3. But 2 doesn't divide by 3, so I don't want to write it like that. So if you went here and tried to break this up, what's the closest number to 2 without going over that divides by 3? There is no number smaller than 2 that divides by 3. That means that the third root of x squared is already simplified. He's done. He's not going to change. So he is done, already simplified. You can't change his answer. So his answer is just the third root of x squared. You don't change it. It's the same thing. What if you were asked to take the third root of x, right? Well, then technically the shortcut would say it would be x to the power is 1 divided by root 3. Well, I don't want to do that because 1 doesn't divide by 3. So again, if you tried to break him up, what's the closest number to 1 without going over that divides by 3? There isn't one. So he is already simplified. You don't do anything to him. This is a done problem, okay? Your answer is just the third root of x. It doesn't change. Okay, so we've seen what to do. Now let's put it all together and practice on some homework problems. Okay, here we go. On your homework, you're going to be asked to simplify questions like this. What is the third root of 125 times x to the third times y to the 15th? Well, just like our square roots, the first thing I do is, since everything's attached by multiplication, I just put everything under their own third root, and I deal with my numbers, my x's, and my y's individually. So let's split everything. Let's rewrite this as the third root of 125 times the third root of x to the third times the third root of y to the 15th. So again, I like to put everything under their own third root and deal with them individually. Well, let's see. Can I take the third root of 125? Go to your list. Is 125 on this list? It is. That means he's good to go. You don't have to split him up or anything. The third root of 125 is 5. So he's 5. All right, the third root of x to the third, does 3 divide by 3? Yeah, so he's good to go. I don't have to split him up. This is going to be x to the 3 divided by 3 is 1. It's x to the first, it's x. All right, the third root of y to the 15th, does 15 divide by 3? Yeah, 15 divided by 3 is 5. So he's good to go. I don't have to split him up. The third root of y to the 15th is going to be y to the 15 divided by 3 is 5. And now, because everything was a perfect third power, nothing is stuck under the radical. That's just your answer. This times itself 3 times will equal that, okay? All right, and again, you can prove it. This times itself 3 times will equal that. So 5x y to the 5th times 5x y to the 5th times 5x y to the 5th, right? This times itself 3 times. 5 times 5 times 5 is 125. X times x times x is x to the third. Y to the 5th times y to the 5th times y to the 5th is y to the 5 plus 5 plus 5 is 15. So it equals that. So it's definitely the right answer. Okay, what if they asked you to simplify the third root of 9 x to the 16th y squared? Well, again, the first thing I like to do is split it all up and deal with everything individually. So let's deal with the third root of 9 times the third root of x to the 16th times the third root of y to the 12th. All right, here we go. Let's do the numbers first. The third root of 9. Go to your list of numbers. Is 9 on here? No. It's somewhere in between 8 and 27. So that means you're looking for the biggest number on this list that divides evenly into 9. And remember, we don't really count 1 because it doesn't change anything. All right, so what is the biggest number on this list that divides evenly into 9? Nothing, which means he's a simplified radical. He is not going to change. He is forever stuck under that radical, okay? So we're just going to leave him as the third root of 9. I cannot break him out. I can't break him up or change him in any way. He's just going to be the third root of 9. All right, the third root of x to the 16th. Does 16 divide by 3? No, so we got to split him. We're going to split him up into the third root of x to the, what's the closest number to 16 without going over that divides by 3? 15. All right, times the third root of how many x's are left over to get back to 16? Well, 15 plus what gets you to 16? 1. So there's 1 x left over. And then we go to the third root of y to the 12th. Does 12 divide by 3? Yes, which means he's a perfect third power. I don't have to break him up. I could do it right now, but I'm going to wait to the next step. We can just leave him the way he is, and we'll take care of him in the next step. All right, this will be the fun part. This is when you get rid of the radicals that get to go away and leave the ones that have to stay. All right, so the third root of 9 we said does not simplify, so he stays. All right, 15 divided by 3 is 5, so that's now x to the 5th, no more radical. 1 doesn't divide by 3 and I can't break them up. That's the leftover part that will forever be stuck under that radical. All right, 12 divided by 3 is 4, so that's y to the 4th, no more radical. So then to finish it, you multiply anything on the outside together that is no longer under a radical, which would be x to the 5th times y to the 4th, and that's x to the 5th y to the 4th, and then anything that is under a third root radical, you're going to multiply together and put under 1/3 root. So that's going to be times the third root of 9x is left under the radical, and that's it. That is your finished answer. Don't forget your third root, okay? All right, let's try another one. Okay? What if they asked you for 5x squared y times the third root of negative 8x to the 9th y to the 7th? Well, remember, 5x squared y is just hanging out on the outside, waiting to be multiplied with anything that breaks free. All right, let's split all this up. So times the third root of negative 8 times the third root of x to the 9th times the third root of y to the 7th. And let's deal with each one of these individually. So again, just bring this down. We are not ready to use it yet. Okay. Well, what about the third root of negative 8? Well, is negative 8 or 8 on this list? 8 is. That means that you're going to be able to take the third root of negative 8 and get a whole number answer. You don't have to split this up. So I'm just going to leave it right now as the third root of negative 8. You could do it right now if you wanted to. I just wait and do it all in one step. All right, let's see if we can break up any of these guys. Does 9 divide by 3? Yes, which means you do not have to split this up into other x's. You're going to be able to take the third root of x to the 9th just the way he is. I'm just going to wait to the next step. All right, the third root of y to the 7th. Does 7 divide by 3? No. So we're going to have to split this one up. If we can, what's the closest number to 7 without going over that will divide by 3? 6. So we're going to break him up into the third root of y to the 6 times the third root of how many y's are left over to get back to 7. Well, 6 and 1 would get you 7, so just 1 y is left. All right, now we should go through and remove any of the third root radicals that can go away. So 5x squared y is still waiting times. All right, the third root of negative 8. Well, remember, the third root of 8 is 2. So the third root of negative 8 is negative 2. So that's going to be negative 2, no more radical, times. Okay? 9 divided by 3 is 3, so that's x to the third, no more radical. All right, 6 divided by 3 is 2, so that's y squared, no more radical. All right, 1 does not divide by 3. I can't split him up, so he's the one that's stuck underneath forever. He's your leftover third root of y. All right, now we go through, we multiply anything on the outside together. All right, so let's see. 5 times negative 2 times no other numbers is negative 10, okay? X squared times x to the third is x to the 2 plus 3, x to the 5th. So then they're done. And then y times y squared is y to the 1 plus 2, y to the third. And then they're done. And then you would multiply anything that's under a radical together and put it under one radical. But the only thing left under a radical is the third root of y. And that is your finished answer. Negative 10 times x to the 5th times y to the third times the third root of y. Okay? All right, how about this guy? All right, so again, negative 2x is just hanging out, waiting to be multiplied with anything that breaks free. All right, so I'm going to split everything into its own third root radical so I can deal with it individually. This is the third root of 24 times the third root of x to the 14 times the third root of y to the 4th. All right, here we go. So bring down your negative 2x. He's just waiting to be used. All right, the third root of 24. Go to your list. Is 24 on this list? No, which means you can't take the third root of him. So now you're looking for the biggest number on this list, if there is one, that divides evenly into 24. And it is 8, which means I can split him up into the third root of 8 times the third root of, well, 8 times 2 gets you 24, 3. Okay, now we go to the next one. Does 14 divide by 3? No, because powers need to divide by the root. So we're going to split him up. So we're going to split him into the third root of x to the, what's the closest number to 14 without going over that divides by 3? 12. And then the third root of how many x's are left over to get you back to 14? Well, 12 plus 2 would be left over. Okay? All right, good. Now we go to this one. Does this power divide by that root? Does 4 divide by 3? No. So what's the closest number to 4 without going over that will divide by 3? 3, right? So we're going to split him up into the third root of y to the third times the third root of, well, how many y's are left over to get you back to 4? 3 plus 1 is 4. So 1 is left over. All right, now this should be the fun part. We should be able to go through and get rid of some radicals. All right, so again, negative 2x is hanging out, waiting. All right, what's the third root of 8? The third root of 8 is 2. The third root of 3, 3 is not on this list. You cannot take the third root of 3. I know that seems weird, but you cannot. So he's the leftover part that will stay stuck under the radical. All right, what's 12 divided by 3? 4. So that's x to the fourth, no more radical. All right, does 2 divide by 3? Nope, he's the leftover one that is stuck under that radical. All right, 3 divided by 3 is 1. So that's y to the first, no more radical. Does 1 divide by 3? Nope, he's the leftover stuck under the radical part. Okay, so now you're going to go through and multiply anything that is not under a radical together. So that's going to be negative 2 times no other numbers is negative 4. Okay? X times x to the fourth is x to the 1 plus 4, x to the fifth. They're done. All right, and then it's going to be, well, y times no other y's on the outside is y. Okay, then you're going to take anything that is under a third root radical, you're going to multiply it together and stick it all under 1/3 root. So that's going to be 3 times x squared times y. And that's your final answer. Okay? All right, look here. Last one. What if you were asked to simplify the third root of 875 x to the 25th times y? Well, let's split it all up. We have nothing on the outside to worry about, so it's just going to be the third root of 875 times the third root of x to the 25th times the third root of y. Okay, well, let's go to our list. Can I take the third root of 875? 875 is not on this list. So you're looking for the biggest number on this list, if there is one, that divides evenly into 875. All right, so if I'm you, start with a number smaller than 875 and just start testing it on your calculator. Does 875 divide by 729? No, right? Way too big. Does 875 divide by 512? Nope. Does 875 divide by 343? Nope. Does 875 divide by 216? Nope. Does 875 divide by 125? We're trying to find numbers that we can take a third root of. Yes. So 125 is our winner. So that means I can split 875 up into the third root of 125 times the third root of, well, 125 times what got you 875? What did our calculator say? 7, right? Okay, he's good. What about this one? Does power divide by root? Does 25 divide by 3? No. So what's the closest number to 25 without going over that divides by 3? 24. So we can split that into the third root of x to the 24th times the third root of, well, how many x's are left over to get you back to 25? 24 plus 1. So there's 1 x left over. Okay, what about the third root of y? Does 1, the power that is assumed to be there, divide by 3? No. Does anything lower or smaller than 1 divide by 3? No, which means he can't be broken up. That means he is already simplified and you will not be able to change him in any way. He just has to stay the third root of y. All right, here we go. Let's go through. What's the third root of 125? The third root of 125 is 5. The third root of 7 is our leftover, so he will stay stuck under the radical, the third root of 7. All right, power divided by root. What is 24 divided by 3? 8. So that's x to the 8th, no more radical. All right, 1 does not divide by 3. He is your leftover. He is stuck under that radical. And we saw that the third root of y could not be broken up or split or changed because he is already reduced and is stuck under that radical, and he stays the third root of y. All right, let's multiply the outside. That gets me a 5 times x to the 8th.